All right, this problem says to solve by completing the square. Now, I don't mind. You can do this by factoring if it will factor or quadratic formula. I don't recall seeing many complete the square problems, but I will go through that process here with you. So whenever you complete the square, it's number 7, x squared plus 4x and then equals 9. Okay, so whenever you complete the square, you want to make sure your leading term is positive and a 1. If there's a number here, you got to divide it out. So once you do that, you then move the constant to the other side. So normally we have this set equal to 0. And if you want to do quadratic formula, you're going to have to move this over and make it a -9 and solve it. But you should get the same thing. However, with completing the square, you want to move that term over because we're going to pick a term specifically that's going to factor out very nicely. So that term has already been moved over. My leading term is a 1. What we do is we take this middle term, which is 4, and this is the completing the square process. Take that middle term, divide it by 2, and then you square it. You always do that to find that number. So take the middle term, divide by 2, square it. 4 divided by 2 is 2. And then you're going to do 2 squared, and it's going to give you 4. These are the two terms I want to use. I'm going to use both of them for a very specific reason. So now over here, I'm going to write x squared plus 4x. Now I'm going to do plus and a blank. This is the number I'm adding to this side, 2 squared. I'm going to leave it in parentheses just like that, 2 squared. Equals, and whatever you add to one side, you have to add to the other. So over here, instead of writing 2 squared, I'm going to go ahead and write it as 4 because I can simplify over here. Now over here, the reason why I left it is because I want to factor this. And instead of having to go through the factoring process with that 4, there's a shortcut with completing the square that always works nice. It works because we picked this number specifically for that reason. So you're going to do a set of parentheses. The two numbers that have a square on them, the x and the 2, you're going to put them in parentheses together. X and 2. You always take this sign. It should be the same as that one. So x plus 2. And then you take your square and put it on the outside. Now, if you were to FOIL this, x plus 2 times x plus 2, you would get x squared and then a 4x in the middle and then a 4. The 4x is not being ignored. It's not just going away, but this is just a shortcut for factoring. Then you set this equal to 13, and then we're going to solve for x. So to solve for x, we have to square both sides to get rid of square root. Whenever you square a number, you must remember positive or negative. So now this becomes x plus 2 equals positive or negative square root of 13. And then lastly, we're going to subtract 2 from both sides. So we get x equals -2 plus or minus square root of 13. So we got two answers, -2 plus square root of 13 and -2 minus the square root of 13. -2 minus and -2 plus square root of 13. So answer choice B. Okay, so this one we did not see, so I'll go ahead and explain this one here. It says write the expression in standard form, a plus bi. So z is equal to 9 minus 7i. Okay, so this is new. Pay attention to this one. It's not really anything special, but just so you can see. The symbol is different, I guess. So they want you to do z and z prime. So this is like the complex conjugate, okay? We've done complex conjugate, but we haven't seen it in this format. So they tell you that z is 9 minus 7i, okay? And then when you do this z bar, you're going to be doing 9 plus 7i. It's the complex conjugate. That's pretty much what that means. Now, we have been talking about difference of squares, so let me just remind you of that. A squared minus b squared is equal to a plus b times a minus b. So if you see something of this form, note that it will translate to just squaring both terms and putting a minus in between. So that's what I'm going to do as a shortcut. So I'm going to square the 9. It's going to give me 81. And then I'm going to square the 7i. So 7 squared is 49. And then I squared, because you got to square both of them. 49i squared. And then recall, I squared is equal to -1. Okay, so negative times a negative will be positive. So this will give us 81 plus 49. And then when you add those two together, you get 130. That's right, 90, yeah, 130. So this is what you get when you do this z bar. It's just multiplying by the complex conjugate. Okay, just new term. And then once you simplify, we get 130.